Let us look at a few other standard forms of parabola. We've already seen this form, y square equal to 4ax. We've seen how the directrix and the vertex and all are placed. So when you come to this parabola, which looks exactly as the mirror image of this one, the equation is y square equal to 4ax minus 4ax. This minus sign is there because now your x coordinates will take negative signs, and minus into minus will become plus because y square is always positive. And the focus will be here inside. It will be minus a comma 0. The directrix will be on the opposite side at x equal to a. So this is your directrix at x equal to a. The focus is at minus a comma 0. The vertex is still 0 comma 0. The axis is at y is equal to 0. And the parametric form here is minus 80 square comma 280 because you have y square equal to minus 4ax. So x should be minus 280 so that this plus, this minus and minus, they become plus because your y square has to be plus, and y is 280 whole square. So on both sides, so this is 80 square, so 4a square t square. On both sides you'll have the same regardless of what the value is t is of t is, and every t will give you a separate point on this. So as you keep changing t, you'll keep getting different points on this curve. Likewise, this one, for this curve, your y-axis is the axis, right? It's facing upwards, and its equation will be x square equal to 4ay. The vertex will still be 0, 0, right? This will be x square equal to 4ay. Remember, vertex will still be 0, 0, and 0 comma a is the focus. It's lying here inside at a distance a. So on the distance, at a distance a on the opposite side, you'll have a directrix, which will be y is equal to minus a. So your directrix is y is equal to minus a, and the parametric form here is 280 comma 80 square. And likewise, you'll have these quantities for the parabolas of this form, which is basically x square equal to minus 4ai. Once again, you have this minus sign because your y coordinate will be negative and your x has to be positive. Notice the change here. Here your t square term is in the x coordinate region. Here your t square term in this particular thing, 80 square comma 280. For y square equal to 4ax, the parametric form is 80 square comma 280. Here also your 80 square, the t square term is in the x coordinate. Here also it's in the x coordinate, but for these two, the t square term is in the y coordinate region. It's in place of y coordinate because whatever your square is, that can't be t square, right? So for example, y square equal to 4ax, in your y square equal to 4ax, your y is squared, so your t square term has to be the x coordinate. So here your x is squared, so your t square term has to be the y coordinate. Remember that. So that's how it goes. And a lot more things you can find out about the same parabolas. Like if I ask you what is the lattice rectum, what is the length of lattice rectum of this? The first thing is, when you see x square equal to minus 4ay, you should straight away say that okay, 4a is the length. So in all these four forms, this form, this form, this form, and this form, the length of lattice rectum is 4a. But if I ask you what is the equation of lattice rectum, so your focus is here, minus a comma 0. Lattice rectum passes through the focus, so the equation of lattice rectum is y is equal to minus a. And if you want the coordinates of the endpoints, you can put y equal to minus a here, so you'll get x square equal to 4a square. So x will be plus or minus 2a, so you have a minus 2a comma minus a here, and you have a 2a comma minus a here. So these are the endpoints of your lattice rectum. Likewise, you can find out a lot more things about the same. So with this, we complete the other standard forms of a parabola. So other than this form, you have 3 other forms, and these are a few important things to remember about this. Let's move on to the position of a point with respect to a parabola here.